Every video up to this one has run on the same machine, localhost, your terminal, your Postgres instance, nobody watching but you. Taskmaster works. It's just the only person who can prove that is sitting right here. That changes today. By the end of this video, Taskmaster is live at a real domain, running on infrastructure you don't manage, backed by a database you don't have to keep alive yourself, with SSL nobody had to configure by hand, and it redeploys automatically every time you push to main. This is the last video in the series, and it's a different kind of video. Videos 1 through 11 were about building the app. This one is about handing it to the internet. Let's ship it. Why production is a different environment. Everything Taskmaster does right now depends on things that only exist because you're the one running it. A .env file sitting on your machine, a Postgres instance you started manually, a server process you can restart the moment something breaks. None of that travels with a git push. Going to production means answering 5 questions the dev environment let you ignore. Where does the code actually run? Where do the secrets live? Where does the database live? How do you find out something broke before a user tells you? And how does a stranger reach it securely? Same order they'll appear on screen today. Hosting, environment variables, the database, observability, then the domain and security layer on top. Deploying to Vercel. Step 1. Connecting the repository. Vercel is built by the same team behind Next.js, so a Next.js app deploys there with effectively zero configuration. Push Taskmaster to GitHub, then import that repository from the Vercel dashboard. Vercel reads the framework automatically, sets the build command and output directory for you, and gives you a production URL before you've touched a single settings page. Hashtag one-time setup. Nothing beyond a normal push after this. Git remote add origin https://github.com/taskmaster.git. Git push u origin main. Then vercel.com/new. Import git repository. Select Taskmaster. Note: Vercel builds from whatever branch you point it at. Main deploys to production. Every other branch and every pull request gets its own disposable preview URL automatically. Step 2. What happens on every push? Once the repo is connected, deployment stops being an action you take and becomes something that just happens. Push to main, and Vercel checks out that commit, runs npm install and next build in a clean container, and if the build succeeds, atomically swaps production traffic over to the new version. If the build fails, production keeps serving the last good deploy. A broken commit never takes the live site down. Open a pull request instead of pushing to main, and you get the same build on a unique preview URL. Working version of that exact branch you can hand to someone for review before it ever touches production. Environment variables on Vercel. Step 1. Moving secrets off your machine. Your .env file was never committed to Git, which means none of its values exist anywhere Vercel can see them yet. Every secret Taskmaster depends on has to be entered directly into the Vercel dashboard under Project Settings, Environment Variables once by hand. Database URL, postgres // next.secret next.auth URL, https://taskmaster.app. These are the same variable names your app already reads locally. Process.env.database URL doesn't change. What changes is where the value comes from, a local file in development, Vercel's encrypted store in production. Step 2. Scoping by environment. Vercel doesn't give you one flat list of variables. Every value gets tagged production, preview, or development, and a variable can hold a different value in each. This is what lets a pull request's preview deployment point at a scratch database while production keeps talking to the real one, using the exact same database URL name in the code on both sides. Note: Next.auth URL has to match the actual URL of each environment. The production value is your real domain, but a preview deployment needs its own preview URL here, or the auth callback will redirect to the wrong place. Database hosting with Neon or Railway. Step 1. Provisioning a serverless Postgres instance. Localhost Postgres doesn't deploy. It's not reachable from anywhere but your machine. Neon and Railway both give you a real, always-on PostgreSQL database in under a minute, and both hand you back a single connection string that drops straight into database URL. Neon example connection string. PostgreSQL, W, user password at epcoolname 123456.useast2.aws.neon.tech taskmaster, SSL mode require. Neon's serverless Postgres scales connections down to 0 when nothing's querying it, which fits a side project's traffic pattern well. Railway trains that for a more traditional always-on instance with a simpler mental model. Either works. Prisma doesn't care which one is behind the connection string. Step 2. Running migrations against production. Prisma migrate dev was always a development command. It's interactive and willing to reset data, which is exactly what you don't want against a live database. Production migrations run non-interactively with a different command, and only ever move forward. npx prisma migrate deploy. Hash applies already committed migration files, never generates new ones, never prompts, never resets data. Note: run migrate deploy as a one-off, before or during your first production deploy, not on every build. Most teams wire it into a deploy hook, rather than the build command itself, so a failed migration can't half apply on every push. Monitoring, logging, and performance insights. Step 1. Reading what's already there. Every server action and server component that throws in production writes to Vercel's runtime logs automatically. No setup required. The Logs tab on your project shows every request, every console.error, and every unhandled exception, timestamped and searchable, which is the first place to look the moment something in production behaves differently than it did locally. Step 2. Adding analytics and speed insights. 2 Vercel packages turn that raw log stream into something you can actually act on. Analytics tracks real page views and traffic patterns with no cookies and no config, and Speed Insights measures core web vitals, the same metrics Google uses to judge page experience, from real visitors on real devices, not a synthetic lab test. npm install @Vercel Analytics @Vercel Speed Insights. App layout.tsx. Import Analytics from @Vercel Analytics React. Import Speed Insights from @Vercel Speed Insights Next. Export default function root layout children. Return HTML body children. Analytics Speed Insights holding. Note: both components render nothing visible. They're invisible beacons that report back to your Vercel dashboard. There's no separate service to sign up for and no API key to manage. Going live, domain, SSL, and security. Step 1. Attaching a custom domain. A project deployed to Vercel already has a working /vercel.app URL. Attaching your own domain is a matter of adding it under project settings, domains, and pointing your registrar's DNS at Vercel. Either an A record for an Apex domain or a CNAME for a subdomain. Vercel tells you exactly which records to add for the domain you type in. SSL is not a separate step. The moment Vercel verifies your DNS is pointed correctly, it provisions and auto-renews a TLS certificate for that domain for free. There's no certificate file to generate, upload, or ever think about again. Step 2. Security before you share the link. Going live means the app is reachable by anyone, not just people you trust, which makes a short pre-launch checklist worth running once. Confirm Next.js secret is a long random value and not the placeholder from earlier in the series. Confirm every Prisma query is still scoped by user ID the way videos 8 through 10 built it. Confirm .env is in .gitignore, so no secret ever reaches a public commit. And add basic security headers, so the browser enforces HTTPS and blocks a few common attack classes by default. Next.config.js. Module.exports. Access headers. Return source/at. Headers LP. Strict transport security. Value max age 6327200. X content type options. Value no sniff. X frame options. Value deny. Note: none of this replaces the authorization logic already built into every server action. Headers and HTTPS protect the connection between the browser and the server. Who's allowed to touch which row is still, and only ever, require role and the user ID checks already sitting in your code. Recap and call to action. Taskmaster now deploys itself on every push, keeps its secrets off your machine and out of Git, runs on a Postgres instance that doesn't depend on your laptop staying on, tells you when something breaks before a user has to, and serves every visitor over a real domain with SSL that renews itself. That closes the series. Video 4 gave Taskmaster a schema. Video 5 gave it an ORM. Videos 6 and 7 gave it real routes and real authentication. Videos 8 through 10 gave it accounts, ownership, and teams. Video 11 made all of that feel fast and forgiving, instead of correct but clunky. and today, all of it left your machine for good. It was never really about Taskmaster. It's a full-stack Next.js and Prisma production pipeline you now know end to end. And the next app you build with it starts from everything you already have.